So last sample problem for this meeting for us to be able to fully grasp the concepts underlying the computation of deflection. Let us try to compute this sample problem. A 300 mm by 600 mm concrete beam has a simple span of 7 meters and pre-stressed with tendons placed under a uniform cover of 100 mm from the bottom of the section. The beam is to carry a total external imposed loads of 20 kN per meter. Concrete weighs 23.56 kilonewton per cubic meter, and modulus of elasticity of the concrete equals to 22,222 megapascal. Consider concrete will not crack in tension. So let us address first the first question that is being asked on the problem. So the first question asks for the value of the force in the tendons in kilonewton required to attain a camber of 3 mm at midspan of the beam after release of prestressing. So assume that the required force already accounted the effects of the total instantaneous losses. So if you can remember, the formula for the total camber that will be experienced by the concrete element is equal to this. It is just the sum of the deflection due to the prestressing force alone and the self-weight itself. So just remember that our sign convention is this. So upward deflections are negative, downward deflections are positive. So for the case of prestressed concrete beam with straight tendon profile such as this, we know that the deflection at midspan is just equal to this due to prestressing force alone. And for the case of simply supported beam, which is loaded by uniform distributed load W, we know that the deflection at midspan is equal to this formula, 5WL to the 4th over 384 EI. So if you will just substitute the corresponding formulas here on this equation, and the corresponding values of the terms that you are seeing here, we can have this equation. So the sum of those deflection due to the prestressing force alone and the deflection due to the self-weight itself must be equal to 3 mm according to the question. And take note that 3 mm is actually a camber, which is actually an upward deflection. So we have to indicate that it must have a negative sign to indicate that it is an upward deflection. So the sum of these deflections due to the initial, due to the prestressing force and due to the deflection of the self-weight itself must equal to 3 mm uh, camber, which is an upward deflection, because that's why we indicated negative here. So again, the only unknown here on this equation is the P, because that is actually what the first question asks. What must be the magnitude of that P so that if we will add the deflection due to the prestressing force alone and the deflection due to the self-weight, the total deflection will be equal to -3, which is an upward deflection. So the magnitude of EC here is just actually equal to the half of the depth. So the depth is indicated as 600 mm on the question, and half of it is equal to 300 mm, and it was specified that the cover of the prestressing reinforcement with respect to the bottom of the beam is equal to 100 mm. So we just have to subtract that 100 to this half of the depth. So half of the depth is 600 over 2. So we just have to subtract this distance, this cover here, which is 100 mm, according to the question. And then substitute the corresponding length of the beam, which is 7,000 mm. And the corresponding modulus of elasticity, which is 22222, 2222 megapascal, and the moment of inertia of the beam, which is just a rectangular section. So the moment of inertia of a rectangular section is equal to bh cube over 12. And then add the deflection due to the own weight of the beam. So again, there is no W given on the problem, but we can easily compute it by utilizing the unit weight of the concrete indicated here. So we just have to multiply it by the area of the cross section, which must be in terms of meter, so that the units will be consistent, so that the resulting unit of W will be equal to kilonewton per meter, which will be converted to Newton per mm for consistency of units, and you can find out that the conversion will have the same magnitude. So you can just directly substitute the values here. And then the length is just again equal to 7,000 mm, modulus of plasticity and moment of inertia, still the same as this terms that you are seeing here. So again, we just using your calculator, the shift solve function of your calculator, you can find the magnitude of P. And again, take note the P that we have indicated here is already in terms of kilonewton. That's why we have a conversion factor 10 cube here is to convert the kilonewton force that we will solve here on this equation to Newton. So this is the conversion factor to Newton. So if you will try to use your calculator, the shift solve function of your calculator, you can see that the magnitude of P, the pre-stressing force that must act on the tendons, must be equal to 402.10 kilonewton. So that the total camber that will be experienced by the concrete element is equal to negative 3 mm. And then to address the second question asks the value of the pre-stressing force in kilonewton required to balance the entire gravity of loads. So if you can remember again, the total short-term deflection is equal to this, which has a sign convention equal to this. Again, negative for upward deflection, positive for downward deflection. So the only negative, the only downward, the only upward deflection here is the deflection due to the stressing force. The rest of the deflections are downward, so that then the sign of those deflections must be positive. So the second question asks the magnitude of the pre-stressing force that will balance the entire gravity loads. Meaning, when you say balance the entire gravity loads, meaning the deflection must be equal to 0. So the total deflection must be equal to 0. So the question asks what must be the magnitude of the pre-stressing force so that when you add the deflection due to that and due to this imposed loads here, the sum will be equal to 0, meaning the gravity loads are already balanced. So if you can remember, the formula for the deflection due to pre-stressing force alone is equal to this, and the deflection due to the imposed uniform loads are just equal to this. So we will just sum up all of the imposed loads as a total W load. So again, that summation, according to the question, must be balanced, meaning their sum must be equal to 0. So substituting the corresponding terms needed here, and then indicating the pre-stressing force as simply P in kilonewton again, because the question asks in the pre-stressing force in terms of kilonewton. So we must convert it into Newton for the equation to be consistent, for it to be in terms of Newton. So we just multiply it by the conversion factor 1000 or 10 cube. So again, the rest of the terms here are just the same as before. The only different term is the W, because now we need to consider the uh, additional load of 20 kilonewton per meter, because it is included on the entire gravity loads. So again, uh, the entire gravity load is composed of the dead load, the superimposed dead load, and the live load. So for this case, the sum of the superimposed dead load and live load are already indicated as 20 kilonewton per meter. So we just have to add it to the magnitude of the self-weight, which is equal to this. We already computed it a while ago. So we just have to add the sum of the superimposed dead load and live load, which are already indicated on the question as a total of 20 kilonewton per meter. So that is the only different term here on this particular question. So again, using your calculator, using the shift solve function of your calculator, we can solve for the magnitude of P, which will be equal to this. So meaning the pre-stressing force must be equal to 618.65 kilonewton, so that when the 20 kilonewton per meter load is applied to the concrete element, the total deflection that will be experienced by the beam will be equal to 0, meaning there will be no deflection, meaning the entire gravity loads are balanced by the deflection due to the pre-stressing force. That is what we meant by this term here, to balance the entire gravity load. So the magnitude of the pre-stressing force must be equal to 618.65 kilonewton, so that this upward deflection here will balance the downward deflections of will balance the downward deflections that are due to this imposed loads, which are the dead loads, superimposed dead loads, and the live loads.